Hello everyone, I am Jay Upadhyaya. Now I'm presenting a presentation on optimizing laboratory process with advanced furnace technology from ambient to 3000 degrees Celsius. Let's start with the Pyrotech group. As a Tempsen, we are a part of a Pyrotech group which is divided into three element division. The first division is panel division, the second is thermal and cable division, and the third is electronic division. So as a Tempson, we are a part of thermal and cable division. Of revenue in the Pyrotech group, we acquire around 57% of share in Pyrotech group as a part of thermal and cable. So next, coming to the area of Tempson business. So the 48% of the major revenue come from the temperature sensor, where we manufacture contact and non-contact type temperature sensor. The 34% share of the Tempson group come from the cables, and the 18% come from the heating solutions. So we have a total of 800 plus employees and over 6,500 customers with over 40 plus years of experience, and we have a wide sale all over the globe of around 75 countries. We have 5 global locations and having 12 patents award, and we have a yearly growth of about more than 30%. To the revenue by market area, the major share come from the India, then from the Asia Pacific and Europe. Then we are expanding our our group to North America and South America. So let's see the plant in India. So we have 5 plants here in India, which is in Udaipur location. So first plant is temperature sensor. The second is heater and pyrometer. The third plant is for thermowells and furnace, and fourth and fifth are for cables. So we are expanding our branches outside our India. So we have established Tempson in Germany in 2012. Now we have established the Tempson in Jaya, Indonesia, and in Gulf, in UAE, we have established a new Tempson plant. So these are the some of our certificates. We have NABL certified temperature calibration center. We are ISO certified. We are IECX certified. These are some of our key customers. Now coming to the laboratory furnaces, let's talk about what is the furnace. So basically, furnace is an electronic power heating device used in scientific and industrial setting for application including material testing and research experiment. Then the principle of furnace is about the Joule heating principle. So the electrical energy is converted to heat energy. The major formula what we use is P equals to I square R, and the factor considered is the radiation factor. So the methods of heat transfer, the heat is transferred using three methods: conduction, convection, and radiation. How to elect the furnaces? So basically, to elect the furnace, we have to know what are the treatment we want to do. So the treatment majorly consists of drying, ashing, heat treating, annealing, pyrolysis, many others. So these are some photos which you can see of the results after heat treatment. Recrystalline the grain structure. We can stop the grain growth. So now coming to electing the furnace, how we can elect the environment, heating element, and insulation in the furnace. So for a particular temperature, we select a particular heating element made up of some alloy, and for particular temperature, we have different heating insulation material. Like you can say that for 1400 degrees Celsius, we take silicon carbide heating element, and the insulation material is alumina ceramic fiber, where we can introduce an atmosphere of N2, nitrogen, argon, and hydrogen, or a vacuum. So these are the atmosphere and material we can use. Next, coming to the vacuum part. So how to select a vacuum pump in our furnace? So basically, there is a graph showing the range for the vacuum pumps. So basically there are four types of pump what we use. Root vane pump for a rough vacuum, and for ultra high vacuum we go for thermomolecular pump, and accordingly we select the types of pumps. So what are the USPs of Tempsen furnace? So the first USP of our furnace is the heating element selection. We select the heating element very precisely according to the temperature. So it does not cause any problem when we have going to its maximum temperature. For 1200 degrees Celsius, we have FECRAL element, heating element, and if we go further, about 2000 degrees Celsius, we have tungsten, and for 3000 degrees Celsius, we choose a graphite as a heating element. Now, coming to the temperature selection, for a different temperature range, we have different thermocouple as well. So, for a range of 1400 degrees Celsius, we use thermocouple R-type thermocouple, and for a temperature above 1800 or 2000 degree above, mainly we go for pyrometers. It is a non-contact type temperature sensor. Okay. Then in the next part of the USPs of Tempson furnace is a selection of material, insulation material. So the boards, fire brick and microporous and insulation brick, we combinedly use them to maintain the ambient temperature outside the furnace. So basically we arrange a layer of insulation starting from brick to board to fiber blanket, or from the board to fiber blanket as required. And the MOC for the furnaces. So in muffle furnace, where a chamber is created. So for creating a chamber, we use SIC muffle, which high temperature and high calibration rate. And coming to the alumina tube, for the tube furnace, we use alumina tube, which provides us high strength and temperature uniformity for our tube furnaces. So, and in the instrument section, we use high-end controllers, basically from the Eurotham, which are programmable, and we also have the HMI display for the our furnaces. So now coming to the laboratory furnaces, we have majorly six type of furnaces in the laboratory section. So first coming to the muffle furnaces, the muffle furnaces are majorly for around 1200 degrees Celsius. So you can see the image of a muffle furnace, and the first thing is the we have used the FECRAL heating element for a better life cycle. Then the muffle, as I already discussed, is made up of silicon carbide, which provide us better temperature uniformity, less thermal shock. So it's better to it increases the life cycle of the muffle. So then you can see in the image the MF312 open view. You can see we have a door opening to the side of the furnace with a limit switch to keep for the safety reasons to shut off the furnace when the door is open. And coming to the models, we have four models in the muffle furnace. Majorly the models are differentiated uh, in the according to the dimension. The temperature is same for every unit. Its maximum is for 1200 degrees Celsius. The thermocouple which have what we have used in the muffle is N-type thermocouple, and the heating element selected is FECRAL. So coming what we can do in muffle furnace. So for the tailorization purpose, we can introduce a gas purging application. Then we can introduce a vacuum, a pre-vacuum, and heat treatment under vacuum. We can use a programmable controller which have many different segments and level. We can use a RS data logger software or a connector which show the reading in your system, and we can optimize our furnace to the size as required by the customer. So the mainly the muffle are used in for the purpose of annealing, soldering, and enameling, and for material testing, etc. So these are the main basics of muffle furnace. Now we come to the HTF, which is high temperature furnace. So in HTF we have furnace for 1800 degrees Celsius. So It is same like a muffle furnace, but the chamber size is much bigger. So we have a side opening door, and it is the high temperature furnace is basically of three types. We have divided the furnaces on the factors of dimension and the maximum temperature they can reach. So there are basically three furnace: 1400 degrees Celsius, and second is 1600 degrees Celsius, and third is for 1800 degrees Celsius. For different furnaces and different model, we have used different type of thermocouple, and accordingly the heating element according to the temperature. Okay, so next coming to the tailorization in high temperature furnaces. So in high temperature furnaces, we can introduce a gas purging for argon, nitrogen, and oxygen. Okay, then we can preheat the gases for the purging, and we can introduce vacuum and other accessories, other vacuum pumps. Okay, we can introduce the same programmable unit in this furnace, and we can customize the size according to the customer requirement. So basically, the HTF are used in the area of glass melting, high temperature testing for ceramic, firing process, powder metallurgy, hardening, material testing, etc. Now we are coming to our next furnace, which is tubular furnace, which goes to around 1800 degrees Celsius. So the main feature for our tubular furnace are that we use the uh, high density alumina and quartz ceramic tube, which provide us great uniformity and ability to withstand high temperature without cracking. Okay, so we have made the tube furnace according to for easy removal and installation of work tube. So the tube furnace is divided into four categories according to the temperature, which is 1200, 1400, 1600, and 1700 degrees Celsius. The tube ID is around 50 and 80 and the length we can customize according to the customer requirement. Now coming to the types of tubular furnace, what we have. So we have different types of tube furnace. First, let's talk about the split tube furnace. So basically, split tube furnace is a horizontal oriented chamber which we can open the furnace to a particular angle. We can take out the tube and insert the material, which make us easy to load the material inside the furnace. Now coming to the vertical split tube furnace, so we have a vertical chamber which can open which we can open at a vertical section. So these are the same as the split tube furnace, which we can see in a horizontal. The same we can go for a vertical part. And for the next, we have a rotary split tube furnace. So in this, the tube is rotated at a particular RPM according to the loading of the material. If the material, we can go around 3 to 20 RPM. So next, coming to the tailorization part of the tube furnace. So we can modify the environment in the tubular furnace for vacuum and other purging gases. We can adjust the tilt angle, and we can adjust the rotation speed of for the rotary tube furnace. So we can divide the furnace in three zones or many two zones according to the requirement, and we can introduce a cooling system for air cooling and air and liquid cooling for our furnace for faster cooling rate. And the tube material is also modified and can be selected as a alumina tube, fused quartz, and pyrex tube. And these furnaces are mainly used for aging, annealing, brazing, CIM purpose, CVD purpose, and coating, pyrolysis, etc. Now coming to our next furnace, we have a bottom loading furnace for about 1800 degrees Celsius. So the you can see the image. The bottom loading furnace consists of a lifting arrangement, which consists of a tray, or you can say a hearth, which moves vertically from the hearth move from the part of the furnace to the bottom area in the atmosphere, in the ambient atmosphere. So for this we have designed a non-shock, or you can say we have designed the tray according to it that it does not provide any, and it does not transfer any vibration to the workpiece or the loading or the load or the material, you can say. So we can introduce the BLF have is divided into our four categories, mainly divided according to the temperature: 1200, 1400, 1600, and 1800. So the internal dimension for our standard furnace is around 120 by height, width, and depth. Okay, then accordingly the heating element and thermocouples are selected. Now for the tailorization, we can introduce the same like others. We can use a vacuum pump. We can purge a gas in the bottom loading furnace. We can use drying and cooling accessories for our furnace. We can introduce air cooling for fast cooling rate. So this type of bottom loading furnace are mainly used in calcining, firing, sintering, and oxidizing ceramic part. Okay, then dental purposes. So let's see our specially designed dental furnace. So in dental furnace we have a BLF, bottom loading furnace. So it goes to around 1100 degrees Celsius. It is very precise temperature. It has very precise temperature control, and we can use a vacuum system to remove the moisture from the furnace. So you can see in the images we have shown what are the applications we can use in dental furnace. We can overlays, we can inlays, and we can crown the teeth. Okay, we can bridge the teeth for our dental furnace. So now coming to our vacuum furnace, which goes to around 3000 degrees Celsius. So in vacuum furnace, it is very critical furnace. So the maximum temperature is around 3000 degrees Celsius. It Coming to the features, it has a rapid heating and it is very energy efficient. The furnace can operate under high vacuum, ultra high vacuum, and the water cooling jacket is provided to maintain the skin temperature near to ambient. The material holding can be manual or automatic. The maximum vacuum which we have make is around 10 s to power minus 6 m bar. So our vacuum furnace is divided in three categories according to the temperature: 1600, 2300, and 3000 degrees Celsius. So our standard vacuum furnace has around 4 to 7 liters of capacity. The thermocouple sensor are contact type we have C type thermocouple, and in non-contact type we have pyrometers. Accordingly, we have the heating element according to the temperature and the environment in the furnace. So we have for 1600 we have gone for molybdenum, and for 2300 we have gone for tungsten, and at 3000 degrees Celsius we go for graphite type heaters. Now coming to the tailorization in vacuum furnaces. So we can purge the gases in the vacuum furnaces like argon, nitrogen, hydrogen. Now we can preheat the gases what we are purging in the furnace, and we have programmable controller and a response unit in the system for PLC and SCADA. And the furnace is also available in three type of loading, which are top loading, bottom, and front loading. So we can customize this furnace according to the size required by the customer. So in the image you can see we majorly have used three type of heater. First and second are graphite heater, and mesh heater is for tungsten mesh heater. Now, for the application, these vacuum furnaces are mainly used in degassing, pyrolysis, synthesis, and sublimation. Now, coming to the last furnace, we can say it is a oven in our laboratory furnace. So, we have an electric oven for maintaining the temperature from ambient temperature to 500 degrees Celsius. So we have a capacity for oven for around 4 to 40 liters. The temperature is very uniform around throughout the chamber. The maximum temperature is for 500 degrees Celsius. It's mainly used convection method for the transfer of heat, as the all common ovens use. So we use tubular heater in the electric oven. Are used in purposes like drying, heating, thermal testing, hardening, stress relieving, etc. So what all the accessories which you provide with our furnace? So the accessories consist of hand gloves, tongue to pick the hot crucible, heating element, crucible vacuum pumps, gas purging accessories, rotameter, and thermocouple. Now, coming to the instrument, we provide thyristor control, SSR, safety controller for extra safety of our furnace. We use high-end controller like Aerothum 3216, and for better communication and better showing the temperature, we can customize it to SCADA control. Thank you all.